Hi there, this is NekitaNet and welcome to this episode of Office Hours. And there was a slight delay, not only in starting, but also in starting talking, because, well, we've got something extremely useful today to talk about, and I will be monitoring the live stream to see if my lip sync is in sync. So, what did I do? What did I build? long time ago, pardon me, haven't spoken in the last hour or so. It is what it is. But a long time ago, I wanted to be able to stream on my main PC via my streaming PC to you, the viewer. And I've set that up. I haven't set that up in a normal way. No, as the title, states, testing NVenc or NVenc and UDP over Firewire to OBS Studio. You need to change that title and ensure, well, that all is well. Yes, we're public. Great. So, that means if you've got a question, you can ask me live or after broadcast as a comment, but during the broadcast as a live chat question, right? Questions, remarks, those things. But I got a GTX 1050 Ti as an upgrade for my failing video card, a noisy video card, and one of the nice things that is in the NVIDIA 1050 Ti, the GTX 1050 Ti, is that it includes an encoding engine that's called NVenc or NVencode, right? Now, to be able to use that, I couldn't use Ubuntu 17.04, right? 16.04? Let's check that to be completely correct. So, let's switch over to, the Vishera screen, this screen, and I'll be out of frame, but we'll talk, right? Right. So, what I've got here is basically Ubuntu, yes, that's fine, Ubuntu.com, or, well, yeah, sure, why not? Let's take a quick gander at the downloads. And I tried Ubuntu. Okay, yes. So, let's switch back. And, it is Ubuntu 16.04.3 LTS that failed me, or to be exact, that didn't support the NVencode default out of the box with the repositories that are available from Ubuntu. So, what did I do? I installed Ubuntu Server 17.04 as we did in a previous episode of Office Hours, and this experimental or version with better maintained or earlier maintained. How should I say that? Because that's a difficult question to talk about. But 17.04 is like a testing version of Debian. It includes more modern or more recently released versions of packages or programs, and I needed FFmpeg to use the NVencode engine. And I could either compile it myself on 16.04.03 .3 LTS, or I could basically just use, the version that is included with Ubuntu Server 17.04. So, I did. I reinstalled this computer, and as you can see, it worked quite nicely, this little setup. And hopefully, once again, the audio is in sync, because that's one of the main issues you'll have if you want to use this setup. I've got a Firewire port on both computers, on the main PC and on the streaming PC, and I built an Ethernet network upon that with, well, let me check for those who are interested. Pardon me. So I used Firewire -net, the kernel module, on both machines and added a Firewire interface to my etc/network/interfaces file. That's for another video, but basically that's how I built the network between those two computers, and then try to use multiple different ways of streaming this screen to the streaming PC from my main PC. Now, there are a number of quirks. Unicast works over Firewire, multicast unfortunately doesn't. So multicast is basically from one source to an unspecified number of destination systems. That doesn't work over Firewire, it does work over normal Ethernet LAN that you use normally with a switch or a hub or your home router or whatever. That does work, but over Firewire it doesn't work. Somehow that never got implemented in the driver for Firewire, or at least the module, the kernel module for Firewire net, or in other words, Firewire Ethernet or Ethernet over Firewire. So, there's another issue, like stated, that's latency. Normal people, quote unquote, normal people, not IT people, will use a capture card on the streaming PC, capture card or a capture device that introduces limited latency. Around 500 to 800 milliseconds is the max, so that's 0.5 or 0.8 or 500 thousandths or 800 thousandths of a second latency. My webcam introduces around 400 milliseconds of latency as I've set it up right now, which means I can anticipate with my mic how much latency I have to introduce in OBS or slow down the rendering of the audio from my microphone to have proper lip sync. This system, when streaming this, is the slowest factor. And to be frank, I'm seeing a latency with the settings I'm using, I'll show you that in a bit, with the settings I'm using of 1.2 seconds, which means I have to add those 400 milliseconds of my webcam upon that to basically have, well, proper lip sync. Something like that at least. And this broadcast is an experiment, and I'm talking you through this because if you want to do this in this way, which is a very cheap way of doing basically capturing of a screen of another computer, you do have to go through a few hoops, which include latency. And most likely I'm not in lip sync. So I'm going to test that right now to say if I am or am not. And yes, I'm not lip synced properly. So here is a little issue with that. How should I say that? It's a mind warp. Could use another word, but the slowest component is the one that has to be metered for, so adjusted for. So the 1.2 second of this thing, stream, well, first of all, capturing the screen, then putting it to the NVenc encoder inside of the video card and pulling it out, then putting it in an FFmpeg TS packet and then pushing it over Firewire to the other computer, which has to basically receive it in OBS, decode it to raw data, and then put it in OBS. That's the limiting factor. That's at 1.2 seconds. So then you've got the webcam, which has a latency of about 400 milliseconds, and then you've got my speech, which is the fastest. It gets received by this little lapel microphone, goes over a nice little short cable, quote unquote short, into the audio card, and that's raw data that's available. If you go by time, in real time from the point of recording, that's the fastest component. So basically, let me check something, because I've slowed down the webcam to 1.7 or 1700 milliseconds. I'll fiddle with that in the end of the episode of this broadcast, because basically you need to do this either to compile your own FFmpeg, which is for most difficult, or for maintenance purposes, in my case, because I don't want to maintain all that stuff on a system that might get refreshed every couple of weeks, because I experiment on it. No, I need a version of Ubuntu that supports it out of the box. So I used Ubuntu Server 17.04. I put on that Xubuntu and started experimenting with this. And it works, as you can see. We have proper video, and it is most likely, hopefully, in sync enough that it is functional. And you can test sync between a webcam and a camera, well, and a screen capture in this setup very simply. Just go to YouTube and type in stopwatch with milliseconds, and then you can basically in OBS record with your webcam facing the screen, and such a setup as you see now, both views, and then you can determine the latency between the two and then adjust accordingly. So that's another tip for you. But let's go here, and I think we'll go to Vigera, because then you won't have the issue of lip sync. But what you need to do on the source machine and on the machine that has 17.04 of Ubuntu, Xubuntu, Kubuntu, Lubuntu, or whatever version, you need to use this command basically. And I have an offset here because I have two monitors. You maybe have to remove that. I would recommend that if you've only got one screen, or otherwise adjust this according to the position of the screen itself. So this is the x-axis and this is the y-axis. You can use another preset. The low latency, high performance preset is this, which I've used, which I'm using currently, which has a weirdness in itself. I use an iframe update of once every 2 seconds because I am recording this in 24 frames per second, as my webcam is doing as well. So here is something very interesting. My webcam does 24 frames per second over USB with H.264 encoding. So I'm pulling out H.264 encoded video, and the max this Logitech C920 supports is 24 frames per second, or otherwise it will show errors. It will desync quite quickly. It needs those additional frames for focusing itself intermittently and automatically. If you set it to, well, I wouldn't. I've experimented with this extensively, but if you turn off autofocus with, for example, well, V4L2UCP, which is a control panel for XOR for whatever version. If you turn it off, you can attain 30 frames per second, but you'll still desync. Don't ask me how. I don't know. I don't care. I've settled on 24 frames per second. So that's why I put in those 24 frames per second here. I'm using 16 megabit per second. As you can see here, you can use 8, you can use more, you can delete this and just depend on the automatic configuration of FFmpeg. You can even do lossless, because there is a preset for lossless, but over Firewire, OBS will chunk and, well, basically disconnect. On the receiving machine though, as a media source, you have to UDP, well, let's go back one little step, and that is the UDP, target IP and target port have to be on the target machine. Let me check that to be sure. Right. Comparing IP addresses. Yes. So the target IP has to be the machine which runs OBS on the interface that you want to use of that machine. So I've got a Firewire interface with a special IP address and I use that. Now the target port can be whatever you want as long as it isn't used and it isn't a low number. For example, you can use 25,000 or 10,000 or 5,000 or whatever. I use the listen1 as an addition to that, and let me check because I think I've lost something in translation. Yes, there has to be a question mark here to enable this. This basically means that if there isn't a target IP available with that address, it will wait until it becomes available. A little detail, that's how it should work, or at least how I understand this part of this. So on the receiving machine in OBS, you have to go to media sources, or at least add a, as they say, well, or as it is, you have to add in the scenes, in the sources, you have to add media source. And in that screen, and can I show you that? Yes, I can. Give me one moment. All right. Let me drag over this. Right. Yes. Transition. Wonderful. This is my OBS as it is currently running, but I've added the name of the computer with the 1080p to identify it, but you have to add a media source as you can see here. Right. I won't add it, but basically you get a dialog box that you have to fill in and such things. So that's that, right? In the dialog box, for testing purposes at least, let's go back to the full screen, but in the dialog box you have to deselect local file, select restart play back when source becomes active, set input source as above, so with UDP double point // and then an IP address of the target PC or the PC which is running OBS on the interface you want to receive it, which should be identical as this one, also a target port, and then select or deselect use hardware decoding when available. Now you can use it with or without, but if you're determining your latency, so as I'm desynced currently voice to video at least, but when you're determining the proper latency, after that use one and not switch around. Just don't. You'll be glad you didn't, because if you do, you have to redetermine the latency for all video sources and audio sources, right? Okay. So after that, select hide source when playback ends, which happens, which I can show you. Yes, there we are. Are we there? Well, basically, when I deselect a scene, and this is a scene in a scene, two scenes in a scene, but when you switch over to another scene and broadcast that, this interface is despawned, as gamers would say. But basically it goes inactive, and the UDP socket, quote unquote socket, on your network card won't be read. So that UDP with that IP, with that port, won't be read at that point in time. Now, after that, set YUV color range to auto. Just do that. If you have issues with color spacing or pixel format, set it appropriately, but for testing purposes, don't. Just set it to auto. If you experiment on your PC with this first part, with, for example, a different pixel format, which you can do, you can basically just switch it out and re-enable it and make it not live and then live again. And it will be reloaded. Just desync it for a couple of seconds so the UDP socket won't be read, and the network socket, and after that re-enable it by, well, let's show you that again. And pardon me, I have something in my throat. But basically, now it's desynced, and after that I can basically resync it, and it's loading, and there it is again. So let's do that again. Now it's gone, it desynced, closed and stopped reading, and it's loading, and it takes a little while, but that's how that works. Ooh. Dragging screens, but basically that's how this works. Issues: audio. Getting that properly synced and getting that properly in your mind, which latency has to be added or subtracted from what. Well, as you can see, it's not working for me right now, so I've got an issue I've got to figure out. Which comes first? This screen, then the webcam, and then the audio? Or is it this screen and then basically the webcam plus the latency of this screen? And the audio, how much does that have to be delayed? Is it this screen minus the latency of the webcam to have proper audio? I'm not sure. I thought I had it, I hoped I had it, but I don't. So I have to experiment properly to get this all working. Now this is the first time I properly share a little bit of secret sauce, right? This which you're seeing is basically how I get stuff done on the command line. It's not ideal, but it is cheap. Like I said, I'm not using a capture card, I am using the video card on this main computer to encode. Basically the screen is showing itself, it's showing me, so it's encoding the screen I see here and putting it over, well, as I said, over Firewire to the main PC, well, to the streaming PC, over an IP address, and not IP TCP, but IP UDP, which means it's a single direction, which means I'm not running into latency issues which I've seen in high bandwidth applications, in real-time applications for Firewire, or at least with the Firewire -net kernel module on Linux. It's an old module and apparently it's a little bit buggy for some applications. Now, one or unidirectional communication with UDP, it works good enough, although you have latency, the same latency you'll see on a normal Ethernet Cat5 network. It is about, for me at least, 1.2 seconds. And, pardon me, let's see. I can open up the settings, and here you can see I've got two screens, both running at 60 Hz, but currently streaming this computer screen, this 1080p at 24 frames per second, encoding that on the video card takes about 7% of the video engine. So let's full screen that quite quickly so you can take a better look. Here you go. Right, I can drag this over. Oh, that's not nice. Let's make that a little bit smaller, but here you can see it's 7%. Oh, that's almost nothing. PCI bandwidth utilization is 3%. I've got a Gen 2 PCI Express motherboard basically, so that's a by 16 card and it only has 5 GT per second. So normally this should be for this card a maximum of 7.5. Doesn't matter, I'm only using 7%. Well, 3% PCI bandwidth, 8% video engine utilization. Now to give you an idea, doing the lossless got me up to 20% video encoding or video engine utilization. 20%, something like that. Let's say 30, so let's say 35% if you use 444 pixel format. You've got headroom, and it isn't 45%, it was around 20-23%, which means this video encoding engine should be able to do 4K at 24 frames per second encoding, which it supports. That's the funny thing. Let's go back to here, and there is a screen. No, oh, that's my configuration. Right? No. Thermal settled application profiles. No, that's not good. Yes, service limits. Here you can see something very interesting. It supports a 420 pixel format and a 422 pixel format. Right? That's not completely correct, but that's the pixel format it supports currently with this version of the driver, which is 375.66. And let's go back to OpenGL. No. There. That's interesting. VD power. Okay. Here you can see it supports 4K, right? 1920. Yes, here it is. 1920 by 2, so let's calculate that. Let's see the limits, 1920 by 2 and 1080 by 2. That's 4K, right? It supports it. You could even do basically 2 4K screens at the same time if you do some funky stuff for H.264. You can use constrained, progressive, extended, constrained, baseline high, main, and baseline profiles. Now, take a look at this. You can even do 2 8K screens in HEVC main, which means H.265. right? So this 1080, well, it's not a 1080, 1050 Ti, although it isn't a wonderfully expensive video card, and for the money you could better buy an AMD RX 460 or 560, because I bought it and returned it because I needed something specific from the video drivers, which AMD didn't support at the time. But the encoding engine is adequate for a lot of stuff. Now, if you run into issues of frame rates, you have to adjust, of course. That's always the case. So let's not go there, let's not talk about that. But this is a viable setup for people who either have a proper gigabit network, because I am running here on the desk a 100 megabit switch and not a gigabit switch. But if you've got a proper gigabit network between your streaming PC and your main PC, or the PC you want to capture from, screen capture from, this is a viable option. If they're next to each other, you could use Firewire, as I've done, just to make a separate network that doesn't have any errors or latencies or interference from other users on the network. Just a little private IP interface which supports up to 400 megabits per second. And I've tested, although OBS failed, but I've tested lossless streaming or lossless encoding of this screen to that computer, to that streaming PC, and that it worked. Longer, shorter, and then failed, but it worked. The bandwidth is there on the Firewire if you've got a proper Firewire cable, so that's not an issue. Or at least it shouldn't be an issue. I'm unsure why it failed. That's something to experiment with, for me at least. So let's check how long I've been at this live broadcast. 31 minutes and 50 seconds currently. So that just to show you this little text, right? This little a little bit of secret sauce. Oh yes, the restart playback when source becomes active. You can, I think you should leave that selected, but hide source when playback ends. You can deselect that, which means your OBS PC will use more CPU to decode it because it will stay active. This is purely, at least for me, for testing purposes, and I don't mind having that load screen on here. So let's switch out and show you that quickly. The fraction of a second that it takes to load this screen, because it reopens the UDP stream from that other PC. Right. So questions, remarks, information, and let's take a quick gander if there's some information you might want to see, right? I'm not sure, but I do know I have to fix this latency issue with the voice part of the stream. Oh yes, there's one big caveat, currently at least. If you have a slower PC which you're using to do this, be prepared to buy an additional, well, I would say sound card, and put it into the streaming PC, so the receiving PC. Because if you try to use, right, let's drag this over. If you try to use this thing here, and also try to put in the desktop audio, you will have latency up the yin-yang. With that I mean, I've seen in my testing latency of about 4.5 to 5.5 seconds. So get a second sound card, buy a cheap one, buy a proper one, but buy a cheap one. That's fine. Put it into the streaming PC and run jack cable, and I've got one lying right here. Run such a cable with these nice jacks, of course. Run this one from the stream, well, from the PC you're recording that desktop from. Plug it into the audio out or the line level out if you've got one. Unbalanced, of course, but it's a line level output. And put it into the line level input of the streaming PC or the microphone input of that streaming PC. It depends on your hardware which output and which input you need to use, but this is low latency. This is extreme low latency, and it should have exactly or about the same latency as the lapel mic that's directly plugged into the microphone entrance, as is the case in this case of the streaming PC. But get a second audio output, because capturing that audio and using the audio, well, the analog to digital converter in your sound card to create a digital sound and then putting it into the FFmpeg TS stream will introduce so much latency that it is ludicrous to do it that way. You could do this setup basically with a lot extreme, well, quote unquote extreme latency without encoding it in the video card. But the video card is so blazingly fast in encoding its own video signal. It's showing you 1.2 seconds. In reality, it isn't much. Because I'm sharing it on another PC, because I'm using Firewire, because it has to be decoded by OBS and put into a raw format, a raw video format, and then show, it takes time. 1.2 seconds though, it isn't much. It isn't much. It is blazingly fast. Even my webcam, which is directly attached to this computer, only has about 400 milliseconds delay. And it also does that. OBS has to decode, well, not OBS, I'm running it through a dummy interface, a dummy camera. That all takes 400 milliseconds. So to go from 1.2, so 1 second and 200 milliseconds delay to 4 or 5 or even 6 seconds, just by putting in the audio, it's not worth it. Go out, spend $20 on a nice video, audio card, put it in that computer and use a cable that's a couple of euros to negate that issue, because audio lag is one of the worst. Well, lag is one of the worst things, especially for live streaming. I'm looking at myself, knowing I'm desynced, and knowing that my expressions are not properly in sync with the audio. Also, switching scenes with 1.2 seconds of lag is difficult, because at what point do I stop talking, be silent, and click over, and at what point do I start talking once I've clicked over to another scene? It is horrible. The 400 milliseconds was acceptable. 1.2 seconds is almost not acceptable, but this is the cheap way of doing this. If you've got an NVIDIA GTX, which has an encoding engine in it, right, ASICs on the die basically, that starts with the GTX 7 series, I think, so 700, but also the GTX 670, 680, something like that. If you've got that, this is a very cheap solution. You don't have to spend a couple of €100 or 100 euros or 80 euros. So $80, $100 or $200 or more for a capture card. You don't have to. Now, this is for Linux. Driver support on Linux for encoding devices or capture devices is bad. You have to buy the more expensive cards and hope that the drivers that are supported with that or provided with that support what you want to do, are supported by your distribution, are supported by your version of your distribution and such. And then you have to set it up finicky, because for example, external capture cards that use USB to transfer that data that have perhaps 500 milliseconds of delay, hopefully less, but perhaps they need firmware on boot up or at first usage during a boot up of a computer, and forget that firmware once you turn down the computer, shut it off. So the drivers for those are a hassle. I've seen people struggle. I know that people have struggled with that. So you need a more expensive capture card for that. So this is the cheap way of doing it. You need Ubuntu or a Ubuntu derived distribution which supports NVenc in FFmpeg, right? And let's see if I've got that command already, because then we can take a quick gander at that. Do I still have that in my previous command list? Yes. No. Okay, let's do something else. Let's close this. Open up a new terminal and then do right. So let's switch over to the large screen. And it is supported, although I'm not seeing it properly, right? But here you've got it, right? This is the codecs we're using. I could have gone with the 265 with a main profile. For those who know a little bit about that, they know what I'm talking about. But right there it is. But I could have gone with that, but there are licensing issues with the H.265 codecs, so I didn't. Are we there? Are we done? I think so. So let's quickly open that again, just to give you a quick last look at that. Preset can be changed. Your G settings, your video bitrate can be removed or changed. With different presets, you'll get different latency issues. Your target IP can be used, your target port. If you decide to go with multicast, which you can do, do note that you'll saturate your network quite quickly, so limit the bit rate to something sensible. If you've got a gigabit network environment, well, you've got enough space even to do lossless, or you should have, but you'll have perhaps interference from other users of the network. Also, if you use multicast, limit the TTL and the time to live to 1, and you'll add something to the back of this. It is a comparable syntax, but then you'll have to use this and put it in quotes. TTL is 1. Otherwise, you might go outside of your broadcast domain, which you really don't want to, because, well, also don't use a public multicast address, but use something like 239.1.1.1, something like that, check which class of multicast addresses are private and therefore should not be broadcast over your external firewall. So over your router, your cable modem and such, if it is properly configured. Be very careful with multicast because you can saturate and destroy your standing with your internet service provider. Always be careful with that because multicast can be transmitted to the entire internet. You should be careful with that because if you've got a misconfigured firewall, it's not good. Especially if you've got cable internet, then your DOCSIS modem might be wrongly configured and allow multicast to pass over from your private network to your local network to which your neighbors are connected. Don't do that. This is a point-to-point connection with UDP. You can use TCP in this instance, but there are issues with that because TCP requires package acknowledgement and packet control. And with UDP, and especially with FFmpeg TS, it is okay that a certain number of packages fail to arrive. I use the G48 to ensure that a complete record of the then current frame is sent every 2 seconds to the target IP. So even if there's an error that can't be recovered by the decoder, by the H.264 decoder, after 2 seconds, so less than 2 seconds most likely, it will get a complete updated new packet of data as it was shown on the source computer. Now there's an issue with that as well. I've seen with this setup the quality level of the indicated quality level as the encoder shows very much dependent on the preset I've used. So sometimes it's like high quality, that's that iframe, and then it deteriorates quite quickly, and other whiles I've seen it jump from, well, let's say from 10 to 24 to 10 to 24 every 2 seconds. It's an issue. You have to experiment with that because you do want the quality level to be succinct and nice. Now you can calculate based on the pixel format how much maximum bandwidth you should have to use if the entire picture is renewed every second, and set something reasonable in your maximum bit rate. There are a number of scenarios you can do with this, and this is basically, doing this properly is a job in itself. Video production with IP, with H.264 is a specialization in itself. So if you're just a casual streamer or just doing this for fun, don't fuss too much. Ensure that the quality level doesn't fluctuate too much. Does a little bit. Don't worry, as long as you've got enough overhead on the video card, that video encoding engine. And then just enjoy. Be cheap, perhaps, too cheap. But in this case it's very simple. I have to spend at least 200 euros, most likely more, to get a proper capture card, and that's just not in the cards right now. I bought this video card for this purpose, and quite frankly, YouTube doesn't pay enough to warrant that type of investment at the moment. I do have to say, before we end, we have now 471 subscribers. So hopefully, after seeing this, you'll decide to subscribe, like this video, but also subscribe, click the bell, the notification bell, and tick the box so you get updates from this channel regularly. The next video for this channel will be most likely installing VirtualBox on this specific machine after I've tested out and reconfigured the latency for audio for the webcam and for this new streaming setup. Also have to decide which preset I'll use in the future and which type of pixel format, because there is a size difference between using 444 color spectrum and 420 and 422. My camera, the C920 currently, or at least as I've configured it currently, does 422 color space, which is interesting in itself. And you can talk about color space for this stuff for ages. I don't know enough about it, so I won't bore you to death with perhaps false information. And it's this video is long enough, so quick gander at this. And here you go. You've seen what I've... okay, we need to get this out of here. That's just if you decide to use TCP as a transport protocol. But this is it. Right, okay. Let's go to the main scene, and I'll say thanks for watching. I hope you found this interesting. I truly have been at this and getting to the stage for a number of years. I'm not joking. Limited funds for this kind of stuff, and also limited time to do it, and also a lot of frustration of getting this stuff working. Even the webcam in itself, it took 2 years to get that one working with H.264, streamed directly from the ASICs within the Logitech C920. I'm keeping that secret sauce to myself for the moment, at least. If you ask me to consult, pay me a little bit, you'll make it worth my effort to disclose it, but of course it will be different for your circumstances, dependent on what type of system you use. But I got it working finally to some success, and I got some very nice imagery from a webcam that, if you use raw data, do note how much data this all is. This computer has been running now concurrently with this stream for almost exactly an hour. Let's say an hour and a minute. With 420, so that's a pixel format of 420. It has generated almost 8 gigabytes or gigabytes, yes, of raw data that has been transported over that Firewire cable, and that's only 24 frames per second. If I use another preset, I can get with this card, with this monitor, on this PC, with this PCI bus, with this processor, and all the caveats I can put in there, I can get 54 frames per second encoded and sent to my streaming PC over Firewire. It isn't 60 frames per second. I'm unsure if this graphic card with the settings I've got on it does 60 frames per second properly on this screen, but 54 frames per second can be done. So streaming at 30 frames per second shouldn't be an issue. I just limit it to 24 frames per second because of the webcam, because I want to keep it in sync and I don't want OBS to go nutty, right? Yeah, that's it. So this is NekitaNet saying I should have pulled these plugs out earlier, but thanks for watching. Like or dislike this video at your pleasure. Of course, subscribe to the channel, and if you do subscribe to the channel, click the bell and tick the box, the notification bell, so you get all updates from this channel. Yes, the next thing for this channel is getting a mixer. Yes, I have to buy one to ensure that we get proper audio from that computer, because then the fun starts. I can do multimedia editing live for you to see and stuff like that. Perhaps some games. Stuff like that. That's the purpose of the main PC being separate from the streaming PC. Having a PC that is not overtaxed. Right? So, thanks for watching. And yes, I'm going to be a little bit quiet give this latency issue a little bit of time to resolve, and then we're switching over to the end scene. Bye-bye.